All right, in section 2, what we're going to do is we're going to move into another type of sequence. This time it's going to be a geometric sequence. How it differs from the arithmetic. If you remember arithmetic, we always added the same value to each term to get to the next term. This time what we're going to do is we're going to multiply. Okay, and when we multiply, we're going to talk about it as a common ratio, okay, which we'll call R. Okay, so very similar fashion. If you notice, we start with some term, and again, first term we're going to call a sub 1. And then what we're going to do to get my second term is take that a sub 1 times that common ratio to get my third term. We'll take my a sub 1 times r times yet another r. Okay, and then again times the third r. Okay, so for instance, what we look at here is you notice that we multiply by 2, multiply by 2. Okay, that common ratio each time. I could rewrite this as 2. I could write this as 2 times 2. This is 2 times 2 times 2. Okay, or 2 times my 2 squared. Okay. Now, one of the things to notice is when I'm doing this is we get an expression that's exponential. And so we have some tie-ins to the last unit when we talked about exponential and logarithmic functions, in that I have an exponential function here where I have a start point, a sub 1, my first term. I have a rate of change. That b value we talked about back then is now my r value. Okay. So one of the things that we're going to have to also do with these is go in and find out what is that common ratio from time to time. If I just list out the sequence, I may need to go in and find out what that common ratio is. Okay, and so if I think about like we did the other day, if I take 16 times my r, whatever my common ratio is, I'm supposed to get 32. And if I go through and solve that, what I'm going to do is divide both sides by 16. Okay, and r is going to be 2, which we knew. But the piece that I want to look at here is that what I'm doing here is that 32 is a sub 5, and I divided it by a sub 4. Okay, so again, we can get talking about all the fancy little subscripts and stuff, but what I like to look at again is to get my common ratio. What I want to do is simply take any term and divide it by the previous term. Okay, in the same way, I could have went in here and taken 8 divided by 4. I would have gotten 2. 16 divided by 8, I would have gotten 2. So when I'm asked to find the next 3 terms in my geometric sequence, that's exactly what I have to do. I first have to go in and find my common ratio. Now notice a couple things here. Okay, one, my signs are alternating from positive to negative. And once we get to the section where we start talking about is it geometric, is it arithmetic, or is it neither, okay, one of the things that we'll notice is that if I have a sequence that bounces back and forth from positive to negative, I know right now it's not going to be arithmetic. Okay, and so I wouldn't even have to think about checking that. Okay, I could go right into checking to see if it's geometric. Excuse me. And same way, if you think, we talked about how this is an exponential function. Okay, with exponential functions, when my common ratio or my rate of change was greater than 1, we knew we had exponential growth, so my number should be getting bigger. Okay, when I had a number between 0 and 1 as my common ratio, my values are getting smaller. So when I look at this sequence that I have here, because of the fact that it's bouncing back and forth, 1, I know that I'm going to have a negative value. 2, I know that number piece is going to be somewhere between 0 and 1. Okay, so it's kind of planning ahead, thinking about what's going to go on. So when I go after my ratio, okay, any term divided by the previous term. Now it's a pretty easy situation. Okay, but what if I had not had that 1 in there? Okay, and again, I take a fraction divided by fraction. Well, remember, that means we should multiply by my reciprocal and simplify. Okay. But at the same time, what I could do is I could look at my calculator and have that help me out. Okay, so we gotta get good with our calculator. So what I want to do is take the fraction that's in my numerator, put that in parentheses, divide it by the fraction in my denominator. And again, if I use that math button, I can turn it back into a fraction. Because if I start with fractions, I should end with fractions or work with fractions. Okay, so now all I have to do is multiply everything by negative 1/2. Okay, and remember, 1/4 times negative 1/2. You multiply your numerators, multiply your denominators. Multiply your numerators, multiply your denominators, numerators, denominators. Quick and easy check that I can do with my calculator. Okay. If I enter my start point, 1, and hit enter. And now what I'm going to use is that last answer feature where I'm going to multiply it by that common ratio of -1/2. And so I get to -0.5, which is a -1/2. I could turn it into a fraction if I needed. But if I keep hitting it, it keeps doing that. Okay, and so I get to the -1.25, which is my -1/8. Okay, there's my 1/16. And if I'm not sure if that's -1/32, I can check it by changing it into a fraction again, and it is. So you're going to want to be able to make use of your calculator with your geometric sequence and series information. All right, so now what if I want to find a specific term? We're going to have a little formula here again, and it's very similar to the last time when we dealt with arithmetic, in that when I look at my first term, look at my second term, there's that relationship between the number of term that I'm on, n, and how many r's that I've multiplied by. Okay, if you remember with arithmetic, it was 1 less d that I'd added to my original start piece. Now it's the same thing. It's going to be 1 less n that I'm raising to a power, or taking it times that ratio. So when I go and find my 8th term, again, get in the habit of writing, you're looking for a sub 8. Remember, a sub 8 is a number. It's one of the terms in my sequence. Okay, my first term in this case is 2, common ratio. I need to go find it. So take a term, divide by your previous. Now, they didn't tell me it was geometric, so what I really should do then is come in and make sure that that ratio is common, that I get the same ratio when I take the second divided by the first as I do when I take the third divided by the second. So my common ratio 3, n minus 1. So here's n again is 8, so to the 7. Now, also remember, because we're dealing with exponential situations, okay, they get really big really fast and really small really fast. Okay, so don't be surprised when you get some large numbers, and don't be surprised if we get really small numbers. If we have we have scientific notation in terms of some of our answers, that's fine. Okay, so again, I'm going to type it in the calculator just like I see it. So my 8th term is 4374. Okay. So just to show you, 2, my start point, times my common ratio 3. There's my second, third, fourth, fifth, 6th, 7th, 8th term. All right, write a sequence that has 2 geometric means between 48 and -750. So just like with arithmetic, that means we need to find 2 numbers that go between 48 and -750, so that when I find some ratio and I multiply it, 48 will get me to my second, then I multiply by that same ratio, it'll get me to my third, and when I multiply it by my common ratio again, it'll get me to -750. Now, arithmetic mean again was an average. Okay, geometric mean, if you remember from geometry, again, it came into play when we had right triangles and altitudes drawn from the hypotenuse. Okay, but what it is if I multiply 2 values together, okay, they're going to be equal to x squared, so I'm taking the square root. Not a big deal if you remember how to find these or where they come from, but in case you were wondering. Okay, but we're going to set these up the same way that we did with the arithmetic situation. There's my a sub 1. There's my first term. This is my 4th term. And so what that means is that this sequence that I'm dealing with has 4 terms, making n equal to 4. Okay, so when I set up my a sub n, again, n can be any numbered term, so I'm going to go with a sub 4 equals a sub 1, r to my n, which is 4 minus 1. Now, what is a sub 4? A sub 4, a's are always terms in my sequence, so it's -750. First term, r cubed. Okay. Now, when I go into solving this, what I'm going to do first is get that r by itself. Now, I know that this -750 over 48 can be simplified, but I'm not going to right now. I'm going to wait until I punch stuff into my calculator. To undo a cube root, or a cube, we need to use the cube root. Okay. Now, if you know your calculator, and if you paid attention, when you go to that math button again, number 4 is your cube root. Okay, so negative 750 divided by 48 gives me negative 2.5. Now, another way we could have approached this, and I'll use this more often than the cube root button because sometimes we don't have a cube root. It might be a 5th root, might be a 7th root, okay, is remember that idea that a cube root, if I change it to a rational exponent, is also to the 1/3 power. And if you do that, you'll find out that you get the same thing. Okay, and so that was the purpose of us going into that last chapter and going through and talking about the rational exponents and how they are related to radicals. Okay. All right, so now that we know what my common ratio is, negative 2.5, I can go in 48, enter, because I want to do this multiple times. 2.5, negative 120, 300, negative 750. Always do that last one to make sure you get back to that 4th term. Okay, if it's not that value, then you've done something wrong. So negative 120 and 300. All right, so then we still can do a series with geometric. And these can get kind of ugly once in a while because the formula is a little more nasty. But again, geometric series means we're looking at the sum for a geometric sequence. So if I want to find the sum of the first 10 terms in this series, 16, negative 48, 144, negative 432. Okay, I want to add all those up. Now, the book gives this formula. Other books will factor out the first term. Okay, they both work. I prefer the second one, mainly because it just makes it easier in the calculator. So to just kind of show what we're going to do, we're going to plug in what we know. Okay, so if I want to find the sum of the first 10, okay, my first term minus my first term, okay, go find your common ratio. The negative has to come with the 48, divide by 16, negative 3. 10 terms. Notice, we're not dealing with n minus 1 here. Okay, that's the first time we're not dealing with n minus 1. 1 minus my common ratio. Okay. Now, it's easy enough to do this in your calculator. One of the things that I'll always do as I'm going through is I recognize 1 minus a negative 3 is actually 4. You got to be careful when you're typing this stuff into the calculator. But I can type it in exactly as I see it, and I'm fine. Okay. And then divide it by my 4. Okay. Negative 236, 192. Now, sometimes people don't think that makes sense, but again, think about exponential. We're getting bigger and really quickly sometimes. Okay. And so that's why it got really big, and we're alternating positives to negative. If you look at the 16 and the 48, well, just putting those two together, you got more negatives. Then you go to the next pair, negative 432, you got more negatives. Okay, and that pattern is going to continue. Had I done this one, okay, first term, 1 minus my common ratio, 3, negative 3, I'm sorry, to the 10th, and again, 1 minus negative 3 becomes 4. A lot of times when I type that one in, I do it inside the parentheses first, so 1 minus the negative 3 to the 10th. And then I take it times my 16, and then I divide it by 4. I like to do the calculator stuff step by step because sometimes it makes that a little bit easier. But again, I got the same thing. So either one of those two formulas will use, and again, as a reminder, probably a good idea to put those formulas right at the top of your sheet. And if you change to a different side of the paper, write it down again so you have them right there. You will have those available to you on the test.